Okay. So there's one k value, sort of. Right? There's one k value that actually has an equation for it. And these are for expansions or contraction. Right? And there are 4 cases for these expansions or contractions, right? So here's A1, here's A2. So I'll always have 1 to 2. Then you can go the opposite. And then you can go, right? So we have 1, 2. We also have velocity going this way. So you have a V1, V2. V1, V2, V2. So this is a contraction. Again, flow rates are going left to right. So this is a contraction. This is an expansion. Right? And then these other ones are limiting cases of these, right? Where this is called an exit sometimes, and this is called an entrance. So you have 4 cases of these expansions or contractions, limiting cases being entrances or exits. All right, so we actually have quantities for these things too that mean a lot. So you go A2 over A1. A2 over A1s. So for an entrance, right, it's basically 0 because the entrance area is infinite and this is finite. For contractions, this value is less than 1. For an expansion, value is greater than 1. And for an exit, we say that it's infinite because now you're dividing, and right, you say that A2 has infinite area. Right? So those are the cases that we have. And then, if you're in one of these situations, we can then calculate right? Right? You can then calculate the K. You don't need an experiment. And that equation is for an expansion. So and you can actually do it as an exercise where you have A1 going into an A2. You label sort of before I hit the change. We have this layer here I'll call 2, and then you'll have section 3. Flow rates going into this expansion. And you have points 1, point 2, and then you have point 3. So you can actually derive this as extra credit, right, as a system of equations to solve. So you have that A1, V1, A3, V3. That's one of the equations. And then you have A3, P3. This is actually conservation of momentum, conservation of mass, and then we have conservation of energy. Subscripts matter for doing this process. So these are the 3 equations. So, right, and this is your third equation. So big extra credit is to actually derive the k using those two equations, which involves some good amount of math, right? But just remember again, the k is this. So figure out what this k is based on velocities that you don't know. It's tricky.